Okay, so to estimate the value of P, the population proportion of success, use a point estimate X. Well, note, because we're not using mean, we need to do X over N, and we need to make this a proportion. Okay, you technically are using your X value, but you're making a proportion. And again, for these guys, just set up your proportion. Rule of thumb, 3 decimal places. Because these are proportions and we move them to percents, if you move this to a percent, well, say it had like this. If you move it to a percent, you at least get a decimal in your percent now. So rule of thumb, we like to say 3 decimal places. Are we good with this? Setting them up? Remember, your calculator does just the opposite. Your calculator asks you for those, and it will give you the p-hat. Sometimes you're given a p-hat, and then you have to find the x to put it in your calculator. So in this survey, we had to find the proportion interval for a 90% and a 95. So again, we're using the same DC that we used before. 90's in the middle, so we do 1 minus 0.90 divided by 2 to get your ZC. That's your area, find your ZC and your inverse norm. So, and a 95 is 1.96. That's the difference between this one and this one. So if you're multiplying by a larger number, you should get a bigger answer. A larger margin of error pushes your interval out, doesn't it? If you add and subtract a larger number, you get a wider interval. So the 95 would be wider than the 90%. Okay. Construct a 99%. Okay, same way. If you like your calculator's really nice for this. Just go to Stat, go to Test. Now pull up the word interval all the way to the top, because you know you're dealing with intervals. We did a Z interval. We did a T interval. Yeah, so 1 proportion Z interval. You want to do A. Put your X value in. Put your N in. Put your confidence level in. And this is a 99. That's it. The rest it does for you. It even calculates a p-hat for you, so that you don't have to calculate your p-hat. If you want to work yourself backwards, if this is my margin, my interval, and I need to find my margin of error, take this and subtract it from the large one. And here's your margin of error. It works the same way as the other ones. So when you can, use your calculator on these. They're really nice. You don't even have to look up your ZC for your confidence interval. So yeah, so there was our ghost, right? Right on our ghost question. That was weird. I always have a ghost in here. A good ghost. Okay? Now, you wish you wish to estimate with 95% confidence the population proportion of U.S. adults who think the president can do a lot about the price of gasoline. Your estimate must be within 4%. So you need to find the minimum sample size needed within 4%. When you're finding the minimum, that's N. Within 4%, that's E. However, we didn't flip them to percents, we left them in proportions. So you're going to have to move that 0.04, make it be a 0.04, otherwise you're going to get very few in your sample if you divide by 4. Probably just one person in your sample when you round up. So we plug it in, I give you this formula. If there's no preliminary estimate, that means we have to go with 50% say yes, 50% say no. So 50-50. And we always round up on your N. Then they decided, okay, what if they knew a little background information, and they knew that in the past studies, 48% thought the president would do a good job, would do something about the gasoline. So notice the difference here. The reason why this is not that much difference here is look where your 48 and 50, aren't they almost the same? You would notice a big difference if it was 38. But 48 to 50, I'm almost multiplying 50 times 50 if you think about it. So that's why there's not a big difference between those. This one will be more exact, will be a little smaller. Yes?
If you have a question and it just says there are no, or it doesn't tell you like you automatically use
50-50 for this. We're finding the sample size. Otherwise, we always have to tell you, P, in this course we will. You probably will determine that, like in another course somewhere along the line, how confident you want to be. But this one we always give it to you, except for this. Yeah. And polling, I'd always go back to polling. Polling is a perfect example of this, because if someone never ran for office before, which most of them have not, we don't know any prior information about them. So we have to build that base up before we can change it. Find the minimum sample size that you need. I did a couple of these because I know you guys have trouble with the n equals. Minimum sample size, n equals, and again round up. Prior studies showed 28%. Now watch the difference between here. There's a bigger difference between here. When it was too close to 50-50, you didn't really have that much difference. But 28, yeah, makes a big difference. I don't need as many in my sample. Questions?
Are you supposed to?
You just say that you get, if you're more exact on your, if you know your preliminary, your sample doesn't have to be as large, right?
So
Every,
just have a smaller sample because we're more exact.
Because you know background information. Yes. When you know something about something, does it, or aren't you at an advantage? Now, this one, if you use your calculator, it's just so much easier. You did have to add them all up. They all added up to 4,015 because you had to do part over whole for all of them. However, if you use your calculator, life was a little bit easier. Our goal was to get to those intervals. So what they were asking you to do, and I thought this was pretty cool, was to take those intervals and put them on a number line to see exactly where they overlap. Now, all of them pretty much overlapped with somebody else. Here's one. Here's one. Let's see if I can do something. That was one. The green is one. Okay, so this overlapped a little bit here. It kind of shows their overlap. Here's the blue, and then the rest is the gold. Here's the gold. So when you do this, you can kind of see your overlap. Same thing when your candidates are running. If they say Hillary is 34% plus or minus 4%, and Bernie Sanders, I just know, well, that's a bad initial, huh? Bernie Sanders is 29% plus or minus 4%. It looks like Clinton is way ahead. But if we did this, and we actually, oops, let's make her 33. Let's make her 32%. If we did this and we actually added 4 to this, she would overlap his a little bit. So do you see where the margin of error forces you to overlap a little bit? So it kind of narrows down that a little bit.